Okay, this is the present value of annuities video. Okay, so when you're trying to calculate how much money you would need in an account now in order to take out payments over time, you would use a present value of annuity. Now, this is an ordinary annuity formula, which means that you would take out the payments at the end of each period, like at the end of each month or each quarter, each year, or whatever. Okay, the question is, how much would we have to deposit? In other words, how much would we have to have in an account right now? That's why it's called the present value. If we needed to extract payments of $2,500 at the end of each year. Now, we're told that this is an ordinary annuity, but we can infer that because the payments are being taken out at the end of each year. Okay, so the present value is going to be equal to the size of the payment, $2,500, times 1 minus 1 plus our rate, which is 10%, divided by each year, that's 1, to the negative 1 times, this is 8 years, all over 0.1 over 1. And again, you don't have to multiply and divide by 1, but I'm just showing it because of the formula. And we are going to get $13,337.32 after rounding off to the nearest penny. Okay, so that's how much we would have to deposit in right now. How much will we be able to extract out of this account over the next eight years? In other words, we are going to extract money out until the account zeroes out. Well, we're taking money out once a year for 8 years, and we're taking out $2,500 with each payment. So that's going to come out to $20,000 worth of payments that we're going to extract. But we only had to put in $13,000 in order to have done that. So this will be worth $13,337.32 at the that's how much we'd have to deposit. Well, but we're going to take $20,000. Notice I'm subtracting the other way right now. And we are going to get $6,662.68. All right. So in other words, we would deposit $13,000 into the account now. Over the next 8 years, we take out $2,500 a year. And then at the end of the 8 years, we would have extracted all the money from the account. But we would have taken out $20,000 more than, we would put $6,000 more than we actually put into it, because we're making interest along the way from the money that remains in the account. Okay, so again, they're telling us that this is an ordinary annuity, but we would know that and be able to infer it because our payments are made at the end of each period. All right, so how much money would we need to deposit right now in order to take out $875 each month over the next 11 years? Well, our present value would be the size of the payment, $875, times 1 minus 1 plus our rate, which is 9%, and this is monthly, the negative monthly times 11 years over 0.09 over 12. And this is going to come out to $73,155.62. Okay, so that's what we would need to deposit right now. I didn't draw that very well. Okay. But we are going to extract 12 payments each year for 11 years. So we're going to extract that many payments, and each payment is going to be $875. So we'll take out a total of, oops, what did I just do? $115,500. But we only put in $73,000 in to begin with, so we made some interest. How much interest? Well, we're going to subtract, and we'll get 42,000. I'll just put it here. Our $42,344.38 in interest. Okay, I know I'm being redundant, but this, we can infer that this is an ordinary annuity because the payments are being made at the end of each quarter. Okay? So how much money would we have to put in the account now? Well, let's do it. This is going to be the size of the payment, $36.50 times 1 minus 1 plus our rate, which is 13%. And this is each quarter, so divided by 4. Negative 4 times, and this is for 7 years, 0.13 over 4. So this will come out to, I got $66,442.01. So that's what we'd have to deposit right now. But over the next 7 years, we are going to take out 4 payments per year for 7 years, so 28 payments. And we're going to take, our payments are going to be $36.50 each. And so we're going to take out a total of $102,200 into this account, from this account, that we funded originally with $66,000. So how much interest did we make? Well, let's subtract. I got $35,757.99. Okay, so we deposited $66,000 into the account. Over the next 7 years, we extracted $102,000, and the difference came from interest. Okay, I know I'm being redundant, but we can determine that this is an ordinary annuity because the payments are at the end of each day. And so how much do we have to deposit now? That's a present value. Okay, so we are going to say that this is going to be our payment size, which is $65 times 1 minus 1 plus our rate, which is 16%. And this is daily, to the negative daily for 5 years. This comes out to $81,642.51 after rounding off to the nearest penny. Okay, so that's what we'd have to fund the account with today in order to take these payments out. How much are we going to make in interest? Well, we're going to take out 5 years worth of payments 365 times a year. So we'll take out that many payments of $65 each. So we're going to take out a total of $118,625. Okay. But we funded it originally with $81,000. So we are going to make $36,982.49 in interest. Let's just leave it there. That's the amount of interest we're going to make over the life of this account. Okay, last present value problem. Again, we know this is a present value problem because the payments are made at the end of each 6-month period. All right. So how much do we have to fund the account with now in order to take out that size payment every 6 months for 4 years at 12%? So our present value is equal to our $16,500 payment times 1 minus 1 plus our rate of 12% divided by 6 months is semi-annually, so this is twice a year. -2 times 4 years. And this will come out to, looks like $102,461.60. Okay, so we'd have to fund the account today with that much, and we would be extracting, well, let's see. We would take out 2 payments a year for 4 years. Each payment would be $16,500 large. So that comes out to $132,000 that we'd be extracting from the account. So this will come out to a total interest of $29,538.40. Okay? Okay, so here's an annuity due for present value. And they don't have to hit you over the head and tell you that you're dealing with an annuity due. You can always determine that because you're taking the payment out at the beginning of each period. Just like ordinary annuities, this is exactly the same thing, except that we have this little factor tacked on to the end. So this portion is exactly the same thing as an ordinary annuity. The annuity due just tacks that on there. Okay, hopefully by now this has become so redundant. I'm just going to torture you with one of these now. All right, so we know without even being told, it's said explicitly in this problem, but sometimes it won't be, but we can infer that this is an annuity due because the payments are being made at the beginning of each month, and the payment made or received. In this case, we're receiving the payment. Okay, so now, how much money does the account need to be funded with? And by the way, loans work exactly the same way. You could think of this as borrowing money, and then the payments that you're receiving are actually payments that you're repaying the loan with. All right, so anyway, the present value would be the payment size, which is $1,025, times 1 minus 1 plus, this is a rate of 14%, for each month for 8 years. Now here's our extra little factor. This is going to be that right there, 1 plus 0.14 over 12. Okay, this is going to come out to $59,693.08. All right. So that's what we need to fund the account with in order to receive those payments every month. So we're going to, each month, 12 times per year for 8 years, that's that many payments, we're going to receive a $1,025 payment. So we will receive a total of $98,400 in payments. But we only funded the account with $59,693. So we make in interest the difference between those. So we make a total of $38,706.92. Now, if this were a loan, you'd be just looking at it from the other perspective. You'd have borrowed $59,000 originally, and over time you would have to have paid back that amount. So this would have been what you got in interest. And just a little note, all loans are ordinary annuities unless otherwise specified. So you would never have a loan that's an annuity due unless it's specified to be so. So you could calculate a mortgage, a car loan, or anything else by using the ordinary annuity formula.